Right now, something huge is happening. A high-stakes race is on to build the digital foundation that's going to power the entire future of artificial intelligence. And the blueprints? They're being drawn up as we speak. So let's just jump right in.
You know, what's happening in AI has kicked off a kind of modern-day gold rush. But instead of digging for gold or silver, the entire tech world is prospecting for something way more valuable these days: raw, number-crunching, computational power. And the sheer scale of this rush is, well, it's pretty staggering.
Just to give you an idea of what we're talking about, get this. There's a single AI infrastructure project being planned, codenamed Stargate, with a proposed budget of $500 billion. That's $500 billion. And that's not for the whole industry. That's for one project. It really shows you the colossal sums of money being invested to stake a claim in this new frontier.
And all of that brings us to our first big topic, this absolutely unprecedented investment boom, and it's all being driven by the relentless, insatiable demands of AI.
The amount of cash being thrown around here is just mind-boggling. I mean, look at this. Microsoft is planning to spend $80 billion on its data centers next year. Meta is jacking up its spending by 70% to $65 billion. This isn't just a little bit of growth. It's a complete explosion of capital, and it's all pointed in one direction.
But here's the real kicker. You can buy every AI chip on the planet, but they're basically expensive paperweights if they can't talk to each other fast enough. All this new hardware has created a totally new kind of problem. How do you build a network that can actually keep up with this insane level of performance?
So, where exactly is this battle for performance being fought? Well, it's really happening across three distinct but totally interconnected frontiers.
Okay, first up we have scale up. The best way to think about this is like the super fast nervous system that's inside a single hyper-powerful server. It's all about getting those specialized AI chips, the GPUs that do all the heavy lifting, to communicate with each other at lightning speed, all within one box.
Next, we scale out. So now we're zooming out from the single server to the entire data center. This is the network that has to connect thousands of those powerful racks together, weaving them into one giant, massive AI supercomputer, what people in the biz call a cluster. And finally, we have scale outside. This is where things get really wild. We're talking about connecting entire data centers, sometimes in completely different cities, and making them all work together as one single, giant, cohesive brain. This is what you need to train the truly massive AI models of the future.
So, with these three frontiers laid out, a huge conflict is starting to take shape. It's a battle to decide what the technological standards, the actual rules of the road, are going to be for this whole new era of computing.
And right at that first frontier, scale up, the fight is, well, it's a classic story, isn't it? You've got the dominant, proprietary champion going head-to-head with a brand-new challenger alliance that's pushing for open standards.
And this slide really lays out the two contenders. On one side, you have NVIDIA's NVLink. It's the reigning champ, it's mature, it's powerful, but it's a closed, proprietary system. It's their way or the highway. Then on the other side, you've got ULink. This is an open standard backed by a who's who of NVIDIA's biggest rivals and customers. We're talking AMD, Intel, Google, Microsoft, Meta, the list goes on. They're basically betting that an open public highway is going to beat a private toll road in the long run.
And you know what? That same exact battle is playing out at the scale-out level. Think of it like a private, high-speed bullet train versus a familiar open highway system. The train is InfiniBand, another high-performance tech from NVIDIA. The highway is good old Ethernet. And here's the thing about Ethernet. It's estimated to be 40 to 50% cheaper, and pretty much every network engineer on the planet already knows how to use it. Now, a group called the Ultra Ethernet Consortium is working to supercharge it specifically for AI.
And this isn't just wishful thinking. The momentum is real. As researchers are pointing out, Ethernet is closing that performance gap, and fast. This is becoming a genuine two-horse race for who will dominate the data center of the future.
But with all of this technological progress, all this money flying around, and these huge corporate battles, they all face one colossal existential threat. There's a plot twist here that could bring this whole revolution to a screeching halt.
And the question isn't about silicon or software. No, it's about something way, way more fundamental.
The answer is power. Plain and simple, electricity. Goldman Sachs ran the numbers, and what they found is just absolutely jaw-dropping. The US alone will need 47 gigawatts of new power generation capacity by 2030, just to keep these AI data centers running. We don't have it. That's an incredible amount of energy.
This power crunch is forcing companies to get really creative, and in some cases, pretty extreme. You have companies like Crusoe Energy that are literally building data centers at oil fields just so they can run on natural gas that would otherwise be wasted and burned off. And then you have Microsoft committing to buy 100% of the power from the revived 3 Mile Island nuclear plant. Yeah, that 3 Mile Island. These aren't just business deals. It's a desperate scramble to find enough fuel to keep the AI fire burning.
Okay, so let's put all these pieces together. The massive investments, the tech battles, the power problem. What does the AI infrastructure of tomorrow actually end up looking like?
Well, this all leads to a really fundamental shift in how we think about things. The very definition of what a computer is, it's changing right before our eyes. For decades, a computer was a server in a box. In the AI era, the new fundamental unit of computing is the entire rack, a tightly integrated, liquid-cooled system of processors and networking all working as one.
This image really illustrates the new reality perfectly. Remember those 3 frontiers we talked about? Scale up, scale out, and scale outside? They're all starting to blur together. The goal now is to make everything, from the tiny little chiplets inside a processor, to the racks, to entire data centers scattered across the country, function as one single, seamless computer.
And this isn't just a theory, it's already here. Look at NVIDIA's new GP200 system. It crams 72 GPUs and 36 CPUs into a single integrated rack. Or check out Amazon's Ultra Server, which connects 64 of their own custom AI chips across 2 racks. These are the brand new building blocks of AI.
So, the race to build this future is on, fueled by hundreds of billions of dollars and facing some enormous challenges. But it all leaves us with one final, critical question. Is this new world going to be built on open, collaborative highways that are available to everyone? Or is it going to be a series of proprietary, walled-off toll roads controlled by just a select few? The answer to that is going to define the next decade of technology.